Welcome to the session 4 for SQLite. Now we have already seen the installation of SQLite. So let's begin with some concepts of commands and data types. The most important commands are dot commands. These are frequently used and most commonly used commands in SQLite system. These commands do not require any semicolon at the end for terminating the statement. For rest of the statements we require semicolon to end the statements. But for dot commands, there is no such necessity. So let us see certain dot commands here. So one is dot databases. So it is used to show the list and files attached to the particular database. Dot exit is used to exit from the command prompt. Dot headers is the command to show the name of the headers, that is the column name. Dot help is the one commonly used help command which is used to explore the different dot commands that are available under the system like a help section in other interfaces. Then there is a dot mode command which we'll also see in a detail. This helps arranging the columns in a manner which we want to. So there are certain options that are available. For example, we can make columns available in .csv form, that is comma separated value. We can also make them available in a left aligned column. We can also make them available in HTML code, maybe in an insert statement, line format, list format, tabs values, and then TCL. So these are all the different options that are associated with the dot mode command. Then there is a dot quit command which helps system to exit from the particular SQLite 3 system. And then there is a dot show command. So all these settings that you will be enabling, that we have to see in a summary. So we can use dot show command. Along with that, there is a dot tables that is used to see all the tables that are available under one particular database. Dot timer is a command that shows the time that was required for the system to process the command. Now coming on to the command prompt window, we have to connect our command prompt to SQLite 3 database. So we will write SQLite 3 and then we have created a folder in the default location of users Eduonix. The folder name is SQLite. Under that there is another folder DB under which there is a test database which is available for a use for our educational purpose. So let us see whether this database is connected or not. So we can use command dot database. So we see at the system it shows yes, this is the database that is connected to the system. We can use another command dot command say dot tables tables to view the tables that are available under this particular database. So we can see there is one table buyers, employees, genres, invoice, invoice items, media types, music, musicians, playlist underscore famous track. So these are the tables that are available inside this particular database. Now moving ahead to explore one column one by one. So now we saw, now let's start exploring certain options. So for example, we will keep the timer on. So I'm keeping the timer on and now I'll access the tables one by one. So to access the table, we need to write a select statement, SELECT, select asterisk. Select asterisk shows that bring all the columns and rows from one particular table. So we next have to write from where. So we need to explore one table, which we'll do is invoice, and observe it that in dot command statement, I didn't give any semicolon at the end, but in a select statement we have to give it. So if you press enter, it will bring all the entries from that particular table, and in the end it will show you the real time that was required to access the system. So there are around 2240 entries in this one particular table. Now since if we go at the top of the column, if we go at the top of the table, we see that there is no header name that is being available. So let's go at the top of the table. There is no header name that is available. So to enable the header name, we saw the option or command called as .header. So coming on to that SQLite window, we have to write .header on, and now we will try to explore another table, right? Select asterisk means extract all from the table name is buyers, and then semicolon to end the statement. And then if we see, we have got 59 entries, the time that was required, and along with that we are able to see the column names. So there are columns called customer ID, first name, last name, company, address, city, and so on. So these are the column names. Okay. Now coming on to view what all columns are enabled, we can write a command .show. So it will show you all the commands that are currently enabled. For example, headers has been enabled, and there is timer that also been enabled. So and again, so now as we can see, this seems to be less organized. We need to change a mode. Now current mode is a list mode. If you observe it here, there is a current mode that is a list mode. If we want to change the mode, we do not want it to be in a list format. We can use another format. So we can say .mode, say line. Now this line mode will bring one entry per line. So again, let's try this. Select asterisk from buyers, and then if you see, each line has got one entry. So from customer ID till support REP ID, this is one entity, and one entity is occupying multiple lines. So data of one entity is now available in multiple lines. For example, customer ID 57 belongs to the first name Louis, last name Rogers. It has got no company name, address is so and so, and the phone number so and so, the email ID. So this is the detail of one particular entity available in different lines. So one line per data. This is the mode change that we did. Now there is one more option that you saw, that was to indicate how to quit from this SQLite. So the command is .quit. Once you press quit, command prompt will come out of SQLite interface. So far we saw commands. Now it is a time to begin with the second part of this session, that is data types. Now data types specify the type of the data or of the object in the table. All columns, variables and expressions and some type of a data type. Data type has to be specified while table is being created. Now data type of a value is contained with the value itself and not with its container. So now each value stored in SQLite database is of one of the following storage class. So it can be a null type. The value is null or is unknown. It can be an integer type. So the value is a signed integer stored in 1 byte, 2 byte, 3 byte, 4, 5, 6 or 8 bytes depending upon the magnitude of the value. The data can be of a real type. So the value is a floating point value stored in a 8 byte floating point number. The value can be a text. So text is a string storing using database encoding, so UTF-8, UTF-16 or UTF-16 LE sort of things. It can be a blob. The value is a blob of data stored as exactly it was input, so there won't be any changes into the data type. Now there is another type which is called as affinity type. So SQLite supports affinity type of column. So despite of many types of data types, any column can store any type of a value. So for example, if I say text, this column stores all data using null, text or blob. So if you declare a type of a column as text while creating a table, it will be able to store null. It will be able to store text type of a data. It can also store a blob. Another is numeric. So if you create a column with the column type numeric, this column can contain values of all storage classes including real, integer and so on. If for example you create a table with the column as a type integer, the column that uses integer affinity behave as same of the numeric value. So all the values that can be occupied under numeric can be stored under the integer. And then we have a real types. A column with a real affinity behaves as a numeric affinity, but it is forces integer value to a floating value. The only difference is real will force the integer type to go into the floating type. Now in the figure we can see that if his column has a got type integer, it can store int, it can store tiny integer, it can store small integer, medium integer, big integer type of data, it can store unsigned big integer type of data, int2, int8 type of data. At the table we can see the ranges of small int, tiny int, medium int, big int. It's the ranges that has been given in the table for the reference purpose. If it is a text type of a data, it can store character value, variable character value, variant characters, nchar, native character. It can store nvchar, text, or it can also store a blob. If you create a column with a real type of data, so it can store real value, it can store double value, as well as double precision and float. Welcome to session number 5, SQLite Database and SQLite Tables. In dealing with the database in SQLite, we have to see how to create databases, as well as we have to see how to attach the databases when it is the multi-database environment, and we also have to see how to detach the databases. So let's begin with how to create the databases in SQLite, and let's move on to the command prompt. Now as you can see here, we have to create a database at a one particular location. So now we will create a database in SQLite. Under that there is a folder DB that has been reserved for creating the databases, and under that we will decide the name to be given to the database. So first let us quit this, and then let's try to work with SQLite 3 again. So SQLite 3, and under that we have a folder SQLite. In that we have a folder DB. It is the location where we have to create the database. So let's create a database with one particular name, test database 2, and the extension that it requires is DB. As soon as you hit enter, it will show you enter.help for usage hints, and then if you have to check whether database has been created, so we can give a command .databases and then hit the enter. Yes, it will show you main, and under this particular location, that is C users Eduonix, there is a folder SQLite, under which there is a folder DB where there is a database being created, test database.db. Now it's not necessary every time the folder will have only one database in its folder. Now we will see how to use one particular database when it is the multi-database environment. In that case, we are supposed to use attach database option. Let's see how to implement that option. When there are more than one databases at one particular location or in the environment, we have to use the option attach database. So let's see how to use this attach database option in SQLite in the command prompt to choose one of the databases to work with. Now for example, I have 2 to 3 databases here, but out of that I would only like to deal with only one database at a time. So now to attach the database, we have a command called attach database, and the name of the database is, for example, test database 1. And this should be attached as what? That we have to give as the alias name. So for example, testing 1, and then close it. Terminate the statement using the semicolon. Hit the enter. Now if you go and see databases, you'll be able to see there is one main database which is test database 2, and there is testing 1 which actually pointing to the location test database 1. So now whatever activity I perform, for example creating the tables or sorting the data will only happen on the test database one, because this has been temporarily connected using the attached database option. Now in a similar manner, we may not need multiple databases, so we can also detach the database. Let us now see how to detach the database. Coming on to the command prompt. Now the command to detach the database is detach database, and we only have to mention the alias name, for example testing 1, and then terminate the statement. Now if you run databases and check, there is only one database that is connected, that is test database 2.db. So this is about dealing with the databases. Now this part deals with the SQLite tables. So here we have to see how to create tables, how to drop the tables, that is to remove the tables. Here also have to see how to insert data into the particular table. We also have to see select query. That means if we want to retrieve any data, we have to make a use of a select query. So how we have to use select query, that we have to see. Along with that, we'll also focus on update query. That is, for example, if we have to update any table, any row of the particular table, we have to make a use of a update query. So that we have to see how will we update query. And along with that, we also have to see if we have to remove any row from a one particular table, we also have to see how we can delete that particular row using the delete query. So let us begin with the create table in a database. So now coming on to the command prompt, we have to see how to create a table in one particular database. So creating a table in SQLite involves using a syntax named a create table. For example, here we have used create table, and the name of the table is given as new underscore organization, and in the bracket we have to specify the column name as well as the type of the column it is. That means what type of a data this column will hold. For example, here ID is the integer type of the data, name is a text type of the data, then position, it is again a text type of a data, and salary is a real type of a data because there can be floating numbers to it. And now we will see whether this table is being generated or not and has been included under the test database or not. So let us type dot tables and then see whether it is been created or not. Yes, of course we can see. So new organization has been created under the database test database.db. Now suppose if we wish to drop this particular table from the database, we have to write a command drop table, and then very next to the syntax we have to mention the name of the table that we wish to delete or that we wish to remove or drop. So now again if you will check tables, now you won't find new organization on the list. Now the next job is to insert the data into the table that we have created. For our example, we'll keep new organization as it is into the database, and we will try to insert some data into this particular table. So for example, insert into the name of the table, which is new organization, and in the bracket we have to specify the names of the column that we wish to fill. This we write if in case we do not remember the sequence of the columns. So we will mention it in the insert into statement itself, or else otherwise if you remember the structure of the table, we do not have to write any column name. We directly can use values and fill the table. So for time being, we have written the column name, and then very next to the column name there is another keyword values, and in the bracket we have filled the values which we want to be mentioned under the column name. So for example 12, John, and his designation or position is sales manager and salary is 12,000. So let us see if we get it or not, if the data is getting filled into the table or not. So to check whether the data is being filled under the particular table or not, we have to do select asterisk from new underscore organization, and once you hit enter, you'll be able to see yes, 12 John, sales manager, 12,000, and it is a real number. So 0.0 has come at the end, has been filled under this particular table. And if you also want to see the column names, you can also say dot header on, and then again you can run this particular command and you'll be able to see ID, name, position, salary, and the data that is been filled under those columns. 12 John, sales manager, and the salary of a 12,000 is being filled. So let us now understand what SQLite select statement does. So to retrieve any data from any table, we need to use select statement. Now for example, in this example, if you see select asterisk from the name of the table media underscore types. So asterisk indicates bring all the data or fetch all the data that is there in the media types. So once we'll hit the enter, we'll be able to see that there are 2 columns and there are 5 rows in the table media underscore types. All the data has been fetched from the media types. If in case we want to modify this, we can mention the name of the column that we want to extract from media underscore types. So for example, we'll see. So for example, here I'm specifying the name of the column now that I want to extract and fetch from the media underscore types. So select name, so name of the column that I want to extract from media underscore types. Now once I hit the enter, I'll be able to see that there is only one column name that is being extracted from media underscore types. So in this way, either we can fetch the entire data that is available under one particular table, or we can extract the required data from a table which we want to explore and see. Now let us focus on to the update statement. Now for example, in this particular table media types, I wish to update first row, that is I want to change MPEG audio file to MP3 audio. So how I can do is I can write update the name of the table, for example media types, and then what I want to change, I want to change name to MP3 audio. So you will write set name equal to in quotations MP3 audio, since it is a character type of the data, where media type ID is equal to the 1, and then we'll press the enter and we'll again try to view this table. Select asterisk, that means bring all the data from media underscore types. So yes, select asterisk from media underscore types, and now you will see that MPEG audio file has been updated to MP3 audio. This is how we can update the table, any row of the table, without harnessing any other row. Now let us see how to delete a row without harnessing any other row or harming any other row in the table. So for example, let us look at the syntax here. Delete from the name of the table media types, where you want to delete, where media type ID is equal to the 1, that is first row should be deleted. Now let us see again, type select asterisk from media underscore types, and then we'll see yes. So media type ID where it was 1, that complete row is being deleted. This is how we can delete the data from a one particular table without disturbing any other rows of the table. Welcome to the session number 6 for SQLite clauses. In this session, we have to deal with operators. So for example, there are certain arithmetic and comparison operators that are used in SQLite clauses. Then we also have to see how to develop an expression. We'll deal with where clause, which is used for filtering the data while generating reports or retrieving the data. And then we also have to see, we have to join certain conditions using and or clause. Like clause, we also have to see for a pattern search. Similarly, we also have to see a glob clause, then limit clause. We'll also see order by clause. That means if suppose for example we have to arrange salaries in ascending or descending order, we also have to see a group by clause, which will be grouping of our data, having clause, which is under the group by clause, and then also we have to see if we have to avoid repetitive entries in the reports, we have to use a make of a distinct clause. So one on one we'll keep exploring. Let's begin with operators. Now an operator is a character used for SQLite where clause to perform arithmetic and comparison operations. So there are 4 types of operators. Basically, one is arithmetic, second is comparison, third is logical, fourth is bitwise operator. So let us begin with arithmetic operator first. Now first is addition, so which perform addition of the values present on both the sides of the operator. Then subtraction, so subtracts the operand on the right hand side from the left hand side. Then there is a multiplication operator, so multiplies values on either side of the operator. Then there is a division operator which perform the division on the left hand from right hand. Then also there is a modulus operator which performs the division but returns the remainder value. So let us see one of them one by one in the command prompt. So for example, let us say select 12 plus 22, then close it using the semicolon. The answer is being returned as 34. Then select 32 minus 12. So the value returned is 20. Then we'll see multiplication. And then you can say 25 into 25. So 625 is the value that is being returned. Also, we can see a division that can be done. So select 25 divided by 5. So value returned is 5. Let us see something that is related to modulus, which will return the value. So for example, 26 modulus of 5. So value returned is 1 as the remainder. So this is how we can use arithmetic operators to perform certain arithmetic calculations. Let us now come on to bitwise operators and understand what are the bitwise operators. So binary AND or a bitwise AND operator copies a bit to the result if it exists in both the operands. So it basically operates like a AND gate. Second, there is a binary OR operator, copies a bit if it exists in either of the operand. Then there is a binary complement. Now we know at a very basic level, all the numbers in computer work in 1 0 and 0 1 combination. So 1 1 1 0 0 0 0 1, they work in this particular series. So this binary one complement operator is unary and has an effect of flipping bits. So that means ones will be converted to zeros and zeros will be converted to 1, and then there will be a 1 complement that will be generated. Now binary left shift operator, the left operand value is moved left by the number of bits specified by the right operand. Now for example, if I give out any number, say 12, it will be first transferred to the combination of 1 0 and then the number specified in the left, say for example 12 left shift 2, so the number will be shifted by 2 bits and then the result will be generated. Similarly, it's a case with the binary right shift operator. So left operand value is moved right by the number of bits specified by the right operand. So looking at command prompt for bitwise operator, so select 12 and operation has to be performed with 14. So value returned is 1. So that means AND has happened between the 12, a binary version of 12 and binary version of 14, and result is generated as 1. Let us see a next example. Select 12 or to 14 and then the result is been again generated as 1. Now let us see another example. Another example is select 1's complement of 60, which will return the value as minus 61. So after complementing the bits, a carry is generated and minus 61 is the value that is being returned. Next example is select 13 left shifted by 3 and then we'll see the resultant is 104. So now let's take another example for right shifting and then So the result is generated as 1. So 3 bits shifted towards right and 3 bits shifted towards left in a binary version of the number makes such a huge difference. So this is the bitwise operation on the numbers that can be performed under the SQLite. Now coming on to a limit clause, let us see how to implement the limit clause. Now for example, in invoices items, there is a huge data and I am selecting everything out of it. So select asterisk from invoices items. If I hit enter, I would be able to see 412 rows have been populated. But if in case I would like to restrict this data, how can I restrict this data? So for example, I can say select asterisk from invoices underscore items, and then I have to use the keyword limit, and then you have to type how many number of rows would you like to see. So for example 3. So if I hit enter, I'll be able to see the initial 3 rows have been populated. Similarly, you can make changes. You can say 6. So 6 will be generated. You can say 9. So 9 will be generated and so on. So this adds one more feature of limiting the data as per the requirement. Now next is the order by clause. Now order by clause helps the data to be arranged in the order of ascending or of a descending. So let us see how to use the order by clause. Now order by clause helps us to arrange the data either in the ascending order or in the descending order. Now for example, select asterisk from invoices items order by the name of the column which we have to arrange in ascending or descending. So for our example, I have taken total, and then how you would like to arrange it. DESC descending or ASC would indicate ascending order, and I'm maintaining limit to the 10. So after hit enter, so I'll be able to see that total column, the last one, is being arranged in the descending order. If you want, you can keep the header on and then run this output again. So you'll be able to see the total has been arranged in the descending order from 25.86 onwards to 15.86. Similarly, invoice ID can be arranged in the descending order or ascending order, or maybe invoice date can be arranged in the ascending order or descending order. So for ascending order, we have to change the keyword to ASC ascending, and as soon as you hit enter, you will be able to see the total is being arranged from 0.99, 0.99, 0.99 onwards, and since I have limited it to 10, we can increase the limit or we can even reduce the limit. So we'll be able to see it is arranged in the ascending order. So 25.86 is the last one, beginning with 0.99. So by default also it is in the ascending order only. Coming on to a group by clause. Now if I can arrange the rows in a group. So for example, if there are multiple rows with the same country name Australia, if I can group them, so all the Australia will be available in one section, then the other country, then the other country. So all the rows that belong to one country will be available separately. Or maybe, for example, there are 3 entries with the name John, so all of them may be available to me in one section, then any other name, then any other name. So this is the way we can group the given table. So let us see how to group the given table. So for example, if I look here, so select sum of the column salary and name from the table new people to, which is being grouped by name. So if I hit enter, I'll be able to see that the sum of salaries of James and Paul has been generated. If you individually try to see the table without grouping it, so we'll be able to see the difference. So now there are 2 entries with the name James. So 5,000 is the salary amount that is being given to them. And once I do it using the group, I'll be able to see that the sum is being generated for James, and as well as the observation of James has come only once. That is, the row of the James has comes only one. So having clause, let us look at the having clause. Now under the group by clause, there is one more provision of a having clause. So now we can lay a further filtration on the grouped data using the having clause. So let us see how we can do that. So for example, we are selecting columns from invoices items and we wish to group the data by billing country, and further under that we also want to make the total to be available more than 13, say for example. So under the grouped data we are laying a one more filter using the having clause. So once you press the enter, we'll be able to see only those data which are more than 13 are being available to us. So for example, if you look at here 25.86, 13.86, 34, so only 3 rows have come, 404, 411 and 390, and these are the grouped data, and under that there is a one more filter being laid, which is that total should be greater than 13. So having clause basically helps laying a filter over a grouped data. So last here is a distinct clause. So for example, there will be multiple entries with the same name, multiple entries with the same country, but you want unique values to appear. You do not want multiple entries from Australia, say for example, or multiple entries from Denmark, say for example. So we can use a keyword distinct in front of the column name in order to avoid the repetitive entries from the same country or same location. So let us see for example how can we do that. So for example, if we look at here, select distinct billing country from invoices underscore items. Now with the Germany there were multiple entries, with Norway there were multiple entries, with Canada there were multiple entries, but since now we have introduced a keyword distinct, so it has come with one or only single name, that Germany, Norway, Belgium, Canada. Now beginning up with the comparison operator. So double equal to checks if the operands are equal. If yes, shows the condition as true. Then second is equal to checks if operand are equal. If yes, shows the condition as true. Then there is exclamation equal to checks if operand are not equal, then shows the condition as true. Then there is greater than and less than. Check if the operands are equal. If not, it shows the condition as true. Then there is a greater than symbol. Checks if left hand operator is greater than the right hand operand. If yes, shows the condition as true. Then there is the less than symbol. Checks if the right hand operand is greater than the left hand operand. If yes, it shows the condition as true. Then greater than equal to checks if the value of the left operand is greater than or equal to the value of the right operand. If yes, then the condition becomes true. Less than equal to checks if the value of the left operand is less than the or equal to the value of the right operand. If yes, then the condition becomes true. Now exclamation less than, check if the value of the left operand is not less than the value of the right operand. If yes, then the condition becomes true. Exclamation greater equal to, so checks if the value of the left operand is not greater than the value of the right operand. If yes, then the condition becomes true. Now for example, in a table invoices underscore items, there is a column named as total, and now I only wish to extract the data in which total is greater than 13. So while writing this syntax, I can say select asterisk, so all the columns from invoices items where total is greater than 13. So I am comparing using the greater than operator, and then we will see only those rows in which the value of total is more than 13 are only being populated or are only being available to us. We can also see a next example. So let us look at the next example. For now time being, let us say we only want those rows in which the value of total is less than 13. So now using the less than symbol, let us now hit the enter and see. So only those rows have been populated now in which the value of total is less than 13. Let us come on to the next example. So now let us say, for example, we have one table playlist underscore famous in which we would not like to see the row which has got a classical in its name. So we will say select asterisk, that is all columns from playlist famous, where name is not equal to classical, and then hit enter. You will be able to see that row number 12 is missing in playlist ID, and then name classical is not being displayed, which is otherwise displayed if we won't let this condition on the table. So let us see any other example. So let us see one example of greater than equal to. So here select asterisk, that is all columns from invoices underscore item, where total is greater than equal to 15. So only those rows where the total value is greater than 15 will only be populated, as we can see here. So likewise we can use operators for making the comparison to the value we want, to the string we want to compare to, and get the. So coming on to a logical operators now. So now there is an AND operator that allows existing of multiple condition in single SQLite where clause. Then if we have to search in the range, we can use a between operator. For example, where total between 13 and 15. So all the values that lie between 13 and 15 will be populated. We'll see the example in a detail later on. Then there is exist operator. The exist operator is used to search for the presence of a row in a specified table that meets a certain criteria or specifications. Then there is the in operator. Now in operator is used to compare a value to a list of literal values that have been specified. Then there is opposite to it, there is not in operator. So negation of in operator is used to compare a value to a list of literal values that have been specified. Then there is a like operator. Like operator is used to compare a value to familiar values using a wildcard operator. So there are two wildcards to like. Then there is a globe operator is used to compare a value to similar values using wildcard operators. Also globe is a case sensitive, which is not the case with the like operator. Then there is the not operator. Not operator reserves the meaning of the logical operator within which it is used. For example, not exist, not between, not in. So it negates the operators. Then there is the or operator. So again it is used to lay the multiple condition. But here we can say total is equal to 13 or name is equal to the John. So it helps in laying the or clause. Then there is the is null operator to search for those rows where the data for a particular column is null. Then there is the is operator. So it is as good as working with the equal to. Then is not operator, which is as equal to not equal to. Then there is a two line operator which is used to concatenate two different strings and make a new one. And last is the unique operator, searches every row of a specified table for uniqueness. So let us begin with the AND operator first. For example, the example that we took earlier, we'll extend it lying a one more condition. So let us see here, select asterisk, that is all the columns from invoices items where total is greater or equal to 15, and along with that I'm adding one more condition, that is billing country should be equal to child. So now once I press enter, I'll be able to see there is only one row that is being populated, that is invoice ID 88, customer ID is 57, so invoice date is so and so, and I can see that billing country's child has been populated. So in this way we could lay more than one condition for the search criteria. Now let us focus on to OR criteria. So now earlier we said total this and country that. Now we will say total greater than equal to 15 or billing country's child. So it should satisfy these two conditions independently and then bring the rows out. So now you'll be able to see that there are more than one observations that satisfy the criteria. So in this manner, we can join multiple where clauses using the AND or operator. Now let us see something about the between operator. So now in total, we have got many figures. So select asterisk from invoices items where total between 13 and any figure you say. So for example, we can say 15, and then all the items or all the invoices or all the rows where total ranges from 13 till 15 will only be populated. So you won't find any reading or any observation or any value in total which is greater than 15. Similarly, we can write any clause, we can write any range and put between, so search will lie between those given criteria. Now let us focus on to a very interesting type of operator, which is a like operator. So now if we can see here, we have written select asterisk from invoices where billing country like, and in the quotations we have written G percentage. Now like operator has two different type of wildcard. One is percentage and other is underscore. Now percentage indicates that after G there can be any number of characters that can occupy the space, and underscore will indicate that there can be one and only one character that can occupy the space. So now let us see first, if I do it using the percentage, what it shows all the readings that are from Germany and there is no pattern restriction on it. So G percentage indicates that there can be any number of characters after this capital G. Now let us look at second wildcard from a like operator. So if you look at the search criteria here, capital G and then two spaces. So for example, I don't remember what were the characters that were occupying the space, but I could see there was a capital D, and I don't remember there are two spaces what was the character that was occupying that space. But then after those two characters there was MANY that was present in that word. So I will write it in this way, G2 underscore. So that means there can be any characters. So this means there can be two characters between G and MANY. So if I had hit enter, I'll be able to see GERMANY. All the observations that are from Germany have been populated. Now let us see next operator called glob. Now again, like a like clause, glob also has got two wildcards. One is asterisk, which indicates there can be any number of characters, and one is question mark, which indicates there can be only one number of a character that can occupy the space. Now major difference between the glob and the like clause is glob is a very case sensitive. So now for example, you have written G capital. If in case you will write G small, it won't make any search. So let us see. For example, Germany, everywhere Germany there was present has been populated. Likewise, you can make a use of another wildcard in a glob clause itself. So if you look here, select asterisk from invoices items where billing country glob, and in the quotations Germany have to be searched. So G, and I don't remember two characters. So double question mark MANY. As soon as you hit enter, you will be able to get those results where billing country belongs to Germany. So this is a case sensitive, but like is not case sensitive. It won't look for capital or small letters, but yes, for glob, case sensitivity does matter. Now there is one more interesting operator called in operator. In operator basically works like a OR operator. So for our example over here, select asterisk from invoices items where billing country in, and in the quotations you have to write the name of the country. Since it is a character data, so it is also written in the quotations. So Germany, comma Canada, which indicates the country may belong to Germany or Canada. So as soon as you hit enter, you'll be able to see. So the list only where Germany and Canada is present in the billing country has been populated. Likewise, you can also say not in Germany and Canada. So let us see that example. So now laying a search criteria, we will say country not in Germany or Canada. So all those observations or rows where billing country is neither Canada nor Germany will be now populated. So you'll be able to see wherever there was Germany or Canada, those observations or rows are being ignored and rest of them are being populated. So this is all about the comparison operators. But before we proceed with the bitwise operators, let us see there is one more operator called as is operator. So which acts like a equal to. So select asterisk from invoices items where billing country is Germany. So all the observations that belong to Germany are being populated. Similarly, you can say is not Germany. So all those rows where billing country is not Germany will only be populated or displayed.